So now we are going to calculate according to our kinematic equations. Kinematic. So we're going to do the same thing. We want to bring both of our displacements over. And let me go back to our theory. So if we look at our theory, there are a couple of things that we need. If you look at the velocity here, which is what we're trying to calculate, we need delta x and we need t. But t is dependent on delta y. So we're going to need our delta y. So we have both of those measurements. And then we're just going to use these calculations in order to produce our velocity. And this is well known, not only well known, period, but well known to us because we've utilized this quite a few times. X displacement, capital letter Y displacement, meant. So let me make that a little bit bigger. Make that a little bit bigger. I really should wrap this. And I'm going to wrap this. Oops. Wrap. And let's go ahead and put our units in. Okay. So let's go ahead and center and then middle. That's space in between there. And let's just go ahead and get that information. So this is equal to our x displacement, return, and then we have our y displacement. We'll do the same thing here. So we have y right there. So we successfully brought both of those over. Next, we are going to calculate our time of flight. If we, again, look at our theory, the first thing we are going to need before we calculate our velocity is our time of flight. We already have delta x, so we need delta t, and delta t is just going to be this calculation, and we already have most of the information. Well, we already have all of the information. So here we go. We're going to start off with delta t, our time of flight. Time of flight. I'll just put in time. Time will be sufficient. It's clear. And I want to go ahead and, of course, center and middle and all of that good stuff. So remember, the time of flight is going to equal to the square root of a -2 times the displacement in the y direction. Okay, so let's go ahead and put some parentheses around that. And this will define our denominator. Nope, our numerator, not our denominator. And then we're just going to divide this by 9.81. Okay, so we have a time of flight of approximately 16.16 seconds. So after that, we are going to look at our velocity, and I'm just going to call it kinematic velocity. Kinematic velocity. Velocity. All right. And this is going to be in meters per second. So let's center and wrap this. It's going to be equal to the square root SQRT of our, let's go back and look at the theory a little bit. Square root of a negative 2 times y sub 2 minus y sub 1, or they are average divided by this. So let's go ahead and pull this back over. Oh, it crashed on me, or it closed, I believe. So it should still be in there. I'll just go back in. Okay, so we know that this is just going to equal to SQRT, and we know that that's going to be a negative 2 times, no, we already calculated the square. We already calculated all of that. So I'm doing a little extra, read all about it. So we're going to say equals to the x displacement divided by the time of flight. And that's it. All right. So we have our time of flight here. Okay, and we have our x, we have our kinematic velocity right here. In the next video, we are going to look at the percent difference. So we want to see how these two velocities compare. Remember, for Bernoulli, we had 1.5, and for our kinematic equation, we have 1.39. So they're experimentally agreeable to a certain percentage, and we want to find out what that percentage is.